Hi, good morning. This is Troy Davidson, and my presentation is on finding the value of trigonometric functions. My agenda is to do an introduction, module objective, summary of the concept, example, and final tips and takeaways. In my introduction, the six trigonometric functions are any functions that lie in the four quadrants. Our p value is the x and y quadrant that is given to us during an example. Our x and y values are shown at the bottom here. Anytime the x and y values are positive, it will lie in quadrant 1. Our x value is negative, but our y is still positive. It lies in quadrant 2. Our y and x values are negative. They will lie in quadrant 3. And when our x value is positive and our y value is negative, then it lies in quadrant 4. Defining a trigonometric function at any angle. When we use the Pythagorean theorem to find our r value, we use the equation r equals x square root of x squared plus y squared. I'll show you in a bit my example that shows us using that equation to find our x, r, and y values. In my example, I use a, b, and c, but they are interchangeable. These are all used to find the trig functions of a right triangle when our c angle is 90 degrees and we don't know our a and b values. My module objective is to educate on the ways of getting our values. So just like I did from before, I like to use smart trig class. All trig functions are positive in Q1 for A. Sine is the reciprocal cosecant and a positive in quadrant 2. Tangent and its reciprocal cotangent are positive in Q3, and cosine and reciprocal secant are positive in Q4. These are pretty much helpful when you want to try and find any value for your your x and y value based on the location. This helps a lot with bearing problems, finding out positioning in problems. My example is one from the practice homework. This is using the Pythagorean theorem to find the length of the missing side of the right triangle, then finding the value of each of the six trigonometric functions of theta. So in our example, we have a as our theta. We don't know side A, but we know side C, which is 25, and side B, which is 20. Using the Pythagorean theorem, a squared plus b squared equals c squared. Then I use a squared plus 20 squared equals 25 squared. A squared plus 400 is equals 625. If we subtract 400 from 625, we get 225. We do the square root of 225, giving us a plus or minus of 15. Using that, we find these six trigonometric functions using, first we're doing sin, cosine, and tangent. Sine is the length of the side opposite angle theta over the length of the hypotenuse, equaling a over c. With that being said, our a over c is 15 over 25, equaling 3 over 5. Our cosine is the length of a side adjacent to the angle a, theta, which is going to be over the length of the hypotenuse, equaling b over c. B over c is 20 over 25, equaling to 4 over 5. Tan theta is the length of side opposite angle A, and the length over the length of the side adjacent to angle theta. Keep switching up angle A and theta, same thing. Equals a over b. A over b is going to equal to 15 over 20, which equals to 3 over 4. Our cosecant, secant, and cotangent are all the reciprocals of the sine, cosine, and tangent respectively. So just going through this, cosecant is our c over a. C over a equals 25 over 15, which equals to 5 over 3. Secant is the reciprocal of cosine, which is our c over b. C over b is 25 over 20, which is 5 over 4. And our cotangent is our reciprocal of tangent, which is b over a. 20 over 15 equaling to 4 over 3. So I try to keep it short and sweet. Just explaining the concept of the 6 trigonometric functions. These are the foundation for our learning into expanding into trigonometry. I want to thank you so much for your time. My name is Troy Davidson, and this is Math 142, Discussion 3. Thank you.